Hello guys, in this lecture we are going to talk about binomial distribution. The word binomial comes from two. In this case we are talking about two options, success and failure. So we are going to be looking at these objectives. We're going to identify a binomial distribution. We're going to determine the distribution of a random variable. We're going to compute the binomial probabilities, and we are also going to calculate the mean and variance of a binomial random distribution. So the conditions for a binomial distribution are listed down here. We have there has to be fixed number of trials. There will be two possible outcomes, success and failure, like I talked about. The probability of success is the same on each trial. In other words, if the probability of getting maybe ahead is 0.2, it's going to be consistent throughout the trial. Trials are independent of each other, and then x is the number of our successes. So let's illustrate how these conditions can be met using this simple example. We are flipping a coin 5 times, and we are interested in the number of heads. That's our x, and the probability of getting ahead is 0.5. Okay, so let's take a look at this to see if the conditions for binomial distribution are met. So first it talked about fixed number of trials. Is there any fixed number of trials? Yes, because we are told we are flipping the coin 5 times. So our number n is 5. Then two possible outcomes. What do we get when we flip a coin? Two options, head or tail. So we have only two options, so that's good. Then probability of success is 0.5 and it remains the same throughout the trial. And then trials are independent, of course. If you toss a coin and get the first time, the second time you are tossing it, what you get has nothing to do with what you got the first time. Okay, so they are independent. Then success, in this case, we are interested in the number of heads. Okay, so the conditions you can see are met. So this is a binomial random variable or distribution. Okay, so let's go further to look at examples of how we can compute binomial probabilities. Okay, and we are going to continue to illustrate using a coin. In this case, we are going to toss a coin three times, and the probability that head shows up is 0.7. So we are interested in head, number of heads. So that's our x, and our p, probability of success, is 0.7. So the first question is, what is the probability that we get exactly 2 heads out of those 3 tosses? Okay, so when we do that, you can see the choices we have. We can have HHT, meaning that each head appears the first time, head appears second time, and tail appears the third time. Or you can have HTH or THH. Okay. Now, for the first option, HHT is going to be 0.7 times 0.7 and then times 0.3. This is head, head, tail. Remember, if the probability of head is 0.7, then it means that the probability of tail is 0.3 because both have to add up to 1. Okay, so head, head, tail, and then you have head, 0.7, tail, 0.3, head, 0.7. That's the second option, head, tail, head. Okay, the last option is tail, head, head. Okay, so if you multiply these 3, you are going to get, let's use the graphing calculator, 0.7 times 0.7 times 0.3, we get 0.147. So when you multiply these 3, this is going to give us 0.147. If you multiply this one also, it's going to give us 0.147, and you multiply the last one, it's going to give us 0.147. So that means that if we get this as 0.147 multiplied by 3, and that's what we did here, 3 times that, so multiply this by 3, so 3 times 0.147 gives us 0.441. So the probability of getting 2 heads when the coin is tossed 3 times is 0.441. 0.441. Okay, now this is the formula for doing that. Okay, if you want to do it the long way, this is what you do. Probability that x is small x in this case is 2. Okay, now you have a combination right here. This combination is actually telling you how many times the pattern is repeated. In this case, the pattern repeats 3 times. That's what we have right here. So that's the combination. When you do combination, it tells you how many times it repeats. So you can multiply by that particular number. Okay, P is the probability of success. In this case, is 0.7. N is 3, X is 2. So when you plug this in, you can get the answer that you desire. So we're going to go to the graphing calculator to see how we can just compute this to get the same thing. So we're going to go to second vars. That's why we do have a lot of distributions. So you can see all we can do here. I'm going to go up, use the arrow to go up. Now when we go up, we're going to go to A. We have binomial PDF and binomial CDF. Binomial PDF and binomial CDF. Now we're going to choose PDF because we are looking for exactly 2. Okay, exactly 2. If it involves more than two options, then we're going to use CDF. We're going to see that later. Okay, exactly 2, exactly 3, exactly 4, then use PDF. Okay, so we're going to select A. Now when you go here, now you can see trials. That's N. How many times are we tossing the coin? That's 3 times. So I'm going to change this to 3. And then we're going to go down. P is the probability of getting ahead, which is our interest, and that's 0.7. Okay, then X is number of heads we're looking at is 2. We want to get exactly 2 heads, so that's what we need to put in, and then we paste and enter again, and you can see that we get exactly the same thing, 0.441. Okay, so that's binomial PDF when we are looking for exactly a particular number. Now going further, you can see the second question is asking what is the probability of getting at most 2 tosses. At most means that 2 is the highest. So what it means is that we're going to add the probability of getting no heads plus probability of getting 1 head plus probability of getting 2 heads. Okay, so in doing that, we're going to use binomial CDF this time. Okay, so you can do this you did up here. It's going to take you a longer time, but we can use the calculator to do that. All right, so of course this should be small letter B. It doesn't matter really. Small letter B. So we'll go back to second vars, and then I'm going to go up, and I'm going to select number B, which is the binomial CDF. Okay, now the number of trials is still 3. P is 0.7, and then the X value is 2, and then we are going to paste and enter. So the probability of getting at least a 2, at most 2, is equal to 0.657. Okay, the probability of getting at most 2 tosses is 0.657. Now cumulative means you have to start from 0 up to the number that you are looking for. Okay, now if you are asked to find maybe probability of more than 2, then it means you have to do some subtraction. You get this and then subtract from 1. That gives you the upper right. Okay, so that's how we find the binomial probabilities when you are asked to find exactly a number and at least at most n number. Okay, at most means from left to the number. Okay, now let's look at how we can find the mean and standard deviation and variance of a binomial random variable. Now let's look at this example. It says only 25% of the 100 households sampled have at least 1 car. Let X be the number of let's add number here. number of households with at least a car. Find the mean, standard deviation, and variance. So this is the formula for the mean, n times p. So in this case, n is the number of our sample. In this case is 100. And then our p is 0.25. That's the probability of proportion. And then what else do we need to find? We're going to find 1 minus p. 1 minus p is the same thing as 0.75. 1 minus p, sometimes we use q for that. Q is the same thing as 1 minus p. Okay, so now the mean is n times p. What is n? N is 100. That should be small letter n. So that should be 100. Let me do it here. 100 times 0.25. 25, that should be 25. So the mean is equal to 25. Okay, the mean is 25, n times p. And then the standard deviation is going to be the square root of np parenthesis 1 minus p. So what we are going to do is we're going to do it right here. So I'm going to do second. I'll come here, right here. Square root of n is 100, and then times, let me use parentheses, times p. P is 0.25, and then times 1 minus p is 0.75. I close the parentheses and then I enter. So my standard deviation is 4.330. Okay, and then remember what we said: when we have a standard deviation, we square it. That's how we get the variance. Well, what we could have done before was just to find this without the square root. That would be a variance, and then we can find the square root to get the standard deviation. But this is the standard deviation square root. Then to get the variance, you just square what you got. 4.330 squared is equal to that. So could have gotten the variance first and then find the square root to get the standard deviation. So this is 18.749 in 3 decimal places. Okay, so that's the formula for the mean of the binomial random variable. This is the standard deviation and this is the variance. Okay, if you get the standard deviation first, then you are going to square it to get the variance. If you get the variance first, then you have to do the square root to get the standard deviation. Okay, so that is how we do the problems associated with binomial distribution. When we come next time, we're going to look at something else. Thank you. Bye-bye.